What's up guys, this is Massey, welcome to another video. In this video I want to show you how to calculate the radius of the ion's path in a magnetic field. A helium 2 plus ion with charge 3.2 times 10 to the power of negative 19 coulomb and mass 6.7 times 10 to the power of negative 27 kilograms enters a uniform 2.4 Tesla magnetic field at a velocity of 1.5 times 10 to the power of 7 meter per second at right angles to the field. Calculate the radius of the ion's path. So here we have a magnetic field, so that experience magnetic force, and that has to be equal to the centrifugal force. Magnetic force is going to be in terms of B times V times Q times sine theta. B is the magnetic field strength in terms of Tesla. V is velocity in terms of meters per second. Q is charge in terms of coulomb. Sine theta, theta is the angle between velocity and magnetic field direction. In this case it says perpendicular or right angle, so it means that that's 90. So we can simplify to BVQ. That has to be equal to centrifugal force, which will be mv squared divided by r. We need to find out the radius. So if we rearrange it, we're going to have r equals to mv squared divided by bvq. Then I can cancel one of the v with this v. It's going to be mv over bq. M is mass 6.7 times 10 to the power of negative 27. V is velocity, which is 1 times 10 to the power of 7 divided by B, which is 2.4, and Q is 3.2 times 10 to the power of negative 19. So R will be 0.087 meters. Or when you convert it to millimeter, you need to multiply it by 1,000. It's going to be 87 millimeter. Now let's see next example. A proton with mass 1.67 times 10 to the power of negative 27 kilograms moves in a plane perpendicular to a uniform 1.5 Tesla magnetic field in a circle of radius 8 centimeters. So R is 8 centimeter. B, magnetic field strength, is 1.5 Tesla. Q, since it's one proton, is going to be 1.6 times 10 to the power of negative 19 coulomb. We need to find out the velocity. We have magnetic force, and that has to be equal to the centrifugal force because there is no other force. So Fm is going to be BVQ times sine theta, but here it says perpendicular, so it is going to be just BVQ. And here we have mv squared over r. So when you cancel it, it's going to be r equals to mv divided by bq. M is 1.67 times 10 to the power of negative 27. V is not given. BQ, B is 1.5, Q is 1.6 times 10 to the power of negative 19. Actually R is given 0.08 because we need to convert 8 centimeter to 0.08. So V will be 1.5 times 1.6 times 10 to the power of negative 19 times 0.08 divided by 1.67 times 10 to the power of negative 27. That's going to give me 1.1 times 10 to the power of 7 meter per second. That's going to be the velocity of proton.